Hey everybody, welcome back to another edition of Welding Wednesdays. So this one is going to be all about industrial gases in welding. Start off, we're going to go through kind of an introduction. What is an industrial gas? Some of the types, some of the roles they play in society, welding processes and how they use industrial gases, then some safety and what does the future look like for that industry. So to start off, introduction to industrial gases. So what is an industrial gas? They're gaseous materials specifically manufactured for industrial applications. So they kind of fall into four types of categories, three main categories, I would say, which is elements, compounds, and mixtures. So if we look at the elements here on this slide, we can see how good our chemistry brains are, see how well we remember these. So elements are, the pure form out in nature. So we have N. I'm going to pause a sec to see if you can guess them. So N is nitrogen, O2, oxygen, Ag, argon, H, hydrogen, and then He, helium. One thing you'll notice is the O2, when oxygen is like in its elemental form, there's two of them. That's because oxygen is super reactive. So in the upper right-hand corner here of the screen, there's a little picture of the argon, and it talks about the valence shell, so the outermost ring of electrons. And one thing that oxygen does is combine with things very, very easily, and that's why, and that's because that it does not have that full outside shell. So it's very eager to hook up to complete it to get some more electrons there. If you remember that that kind of basic level chemistry, that's why you see things oxidize so much. So iron, food, water, everything kind of oxidizes in a way and changes its properties a little bit. Compounds. So we first have C2H2. Any guesses? C and H, so hydrocarbon. So anytime you see C and an H, you can kind of easily assume that it's going to be something that's used for fuel. So C2H2, that is going to be acetylene. N2O, that's nitrous oxide. C3H8, very common fuel gas. That's propane. H2X, that would be hydrogen sulfide. Some people might not know what hydrogen sulfide is. It is often added to natural gas to give it that kind of sulfury smell or the rotten egg smell, so you can tell if there's a leak because natural gas doesn't have a odor. So that's an additive used there a lot. And then the last one is, I want to make sure I say it right, sulfur fluorohexide, I believe it is. And what that is, it's a gas where it's used as an insulator gas because electricity has a lot of trouble moving through it. So there's some gases that electricity can move through pretty easily or relatively easily, like argon. It can really conduct electricity. That's why we use it a lot for welding. But the sulfur fluorohexide, I believe again, is kind of more of an insulator gas. So they use it a lot with electronics, things like that, where we don't want electricity to move across open space. So elements is pure form. Compounds are where we're going to get multiple pure elements together to make something new with new characteristics. Mixtures are where we're mixing two gases together, but each gas or each part maintains its inherent characteristics, and both of those characteristics, or three or four, whatever characteristics, are all going to be expressed in the use. So for instance, if we look at the first mixture here, Ag/CO2, that's going to be a very common MIG mix or GMAW mix, 75-25, so 75% argon, 25% CO2. Next one, argon, helium, CO2, very often called trimix out there, used a lot for like stainless steel with MIG welding. And then finally, nitrogen and CO2 mix, another one that's out there in the world. Final kind of category here, it's not like a form of industrial gases that we use, but I think it's just important to highlight the noble gases. So those are helium, neon, argon, krypton, xenon, and radon. What makes them noble is we talked just previously here about oxygen not having like a full outer electron shell, which makes it combine with things really easily. The noble gases do have a full exterior shell, so they are inert. They don't combine with things very easily at all, and that's why they're called noble. All right, so let's look at some types of specifically industrial gases. So first we're starting off with oxygen, used a lot in oxyfuel welding and cutting. Oxygen helps to add more heat when you use your fuel source. Another thing with cutting is you need that extra jet of oxygen to be able to rapidly oxidize your steel or iron that you're cutting with your oxyacetylene torch. So that extra like jet helps to rapidly oxidize at an elevated temperature, which is what your cut is. So how it was explained to me once, and I really like it, and let me know if I'm wrong, but you can only use oxyfuel cutting if your material can oxidize at a high temperature. So what that means is you're not really like melting material really. What you're doing is you're rapidly oxidizing in a very controlled way. What else is oxidation known for in iron? Rust. So you're kind of like rusting a very small, very controlled way, and then blowing out that rust, and that's kind of what your cut is, which is pretty cool, I think. Acetylene, again, C2H2, very common fuel gas for high temp welding and cutting. It is not like the highest temp gas that we can use, but it's one of the most common ones. Acetylene is actually getting a lot harder to find in the world. In the US, I know they make it in Texas and Nebraska, and like for us, for MO2, we send a truck to Nebraska every week to drop off empties and get fulls of our acetylene. So there's nothing like real local. Back in the day, people used to make their own acetylene a lot. It's a very simple process. It's just calcium carbide and water. So you put those two together, and then acetylene gas is released. It's very simple, but acetylene is very reactive. So you know it can like explode, or like just it can become unstable at different pressures, different temperatures, things like that. So most people have moved away from using it as either their source for like welding, especially, or cutting, I should say, especially cutting, but also, not making it themselves. Fun fact, back in the day, miners, like people who were digging underground, their headlamps used to be acetylene. So they would have like water, they'd have like a little piece of like calcium carbide and then water, and then you control like the amount that it would drip, and that would control like the level of flame. It's pretty crazy. Right below my head here, you see a cylinder that's cut in half. That's actually an acetylene cylinder. So acetylene is a gas, but as I said before, acetylene gas is reactive, and so you need to kind of stabilize it. So what happens in an acetylene cylinder is it's filled up with that white stuff. That white stuff a lot of times is called diatomaceous earth, which you might not have heard of, but you've probably seen it before. When you are like using potting soil, the perlite, the little like white balls there, that's a lot of times diatomaceous earth. Diatomaceous earth is like a big matrix of like fossils, I guess, from that were laid down from sediment. And so it's kind of like, I don't know, like chalky maybe would be a way to describe it. But what it does is it can hold liquid. That's why like perlite is in potting soil, because it can hold the liquid over extended periods of time. And the liquid that's in an acetylene container is acetone. So same as that you use to like remove nail polish, that sort of thing. So the acetylene is kept in acetone as a mixture to stabilize the acetylene. This is one of the reasons why there are certain like draw rates and PSIs that you can pull off an acetylene cylinder, because if you go above what is recommended or directed as far as like the rate that you're going to be pulling acetylene off, you can start to pull acetone into your system, which is a big problem. It's also why if you have an acetylene cylinder on the ground, like laying down, you have to put it upright, and then it's always a minimum of like 4 hours that it's upright, and that's to allow that acetone to settle back down to the bottom, because it's all moved kind of to the side of your cylinder, and if you hook it up right away and try to use it, you're going to pull acetone into your system, which is bad. Acetone and acetylene are solvents too, so that's why we use some special hoses usually for those. I believe they're the R hoses. They're specifically made to be used with acetylene so that it doesn't dissolve the actual hose. Next, we have argon, a very common shielding gas for MIG and TIG. It's in our atmosphere, like oxygen's in our atmosphere. Carbon dioxide, another common shielding gas for MIG. We produce it every time we breathe. So there's a lot of carbon dioxide out there, but it is getting more expensive because the government has been paying industries to sequester it to prevent more carbon dioxide from getting added into the atmosphere to increase the greenhouse effect. So a lot of industries didn't do a great job of explaining, hey, we need carbon dioxide in our industry. So these companies are getting paid to, sequester it, whereas we still need it for like welding, beverages, that sort of thing. So it has been getting more expensive. There is plenty of it, but there is not a lot to be used for other industries, if that kind of makes sense. And then finally, nitrogen, common shielding for laser applications. Again, that's in the atmosphere. Primary gas in our atmosphere. All right, some of the roles of industrial gases. If we look at outside of welding, so this is kind of like in manufacturing, where we have a lot of customers who aren't using our gas for welding specifically. They're using it for other things. So you look at like oxygen. It's used in blast furnaces. Blast furnace creates steel with using like superheated air. So that oxygen helps to remove the impurities when you're using a blast furnace and creating steel. It's the raw material for chemicals like H2O2. So anybody know what H2O2 is? H2O is water, right? So if you add one more oxygen to H2O, you get hydrogen peroxide, which if we use our good chemistry brains, we can kind of see water like doesn't bubble when you put it on something, but hydrogen peroxide does. That's that reactivity from the additional oxygen for the oxidation. So oxygen is, I know it's a really essential element, obviously, but it's also a pretty cool one. And then carbon dioxide used for dry ice, not just for like sending things or keeping things at a lower temperature. Like if you get something frozen in the mail, a lot of times there'll be like dry ice in it. It's used a lot for our customers for like blast cleaning. So you're actually using dry ice to clean instead of like sand or glass or that sort of thing. Beverage carbonation, of course. Foaming agent in plastic and rubber. So when you are making like a foam, you'll go ahead and have like your plastic or rubber melted, inject carbon dioxide, bubbles up, that's your foam. And then finally, fire extinguishing. So a lot of fire extinguishers are CO2 based. And you might be like, well, hey, the fire triangle is a heat source, or your ignition, a fuel source, and then an oxidizer. So you need those three things to make a fire. So CO2 has oxygen, and carbon is a lot of times what's present in something that's a fuel. How can CO2 put out a fire? It's because CO2 is a very stable like compound. So what happens is you use that CO2, you're able to displace oxygen. It's not as reactive as the things on their own, and there you go, you're able to put out a fire. All right, some more industrial gases for manufacturing. Nitrogen. So we got a bunch of customers who use this for food preservation. Same sort of thing. We're going to put nitrogen in any voids instead of oxygen. to prevent the oxidation of our foods, to prevent them from tasting bad at best or spoiling at worst. It's a raw material for chemicals like NH3. Man, I don't remember what NH3 is right now. Nitrogen and those 3 hydrogens. Ugh, I wish I could remember. Yikes. And then nitrogen is also used for liquid cooling and freezing. Hydrogen is used a lot for refinement of crude oil into other types of hydrocarbons to use. Hydrogen fuel source in cells, hydrogen fuel cells out there in the world. And then it's also essential for production of like high purity glass and semiconductors. And then we have our rare gases like our xenon, neon, those noble gases, used a lot in lighting, refrigeration, precision cutting lasers, that sort of thing. All right, so let's look at specifically welding processes and gases, how we use them. So what the gas does primarily in welding is it provides shielding. So molten metal and atmosphere, we don't want them combining because you're going to get a lot of porosity. You're not going to get as structurally sound welds. We want to try to keep atmosphere out of the molten metal. So what we use then is a shielding gas. Argon is very common for GMAW. Use it for non-ferrous metals and steel blends. CO2 provides deeper penetration for like carbon steel. So that's a lot of times why we will go ahead and combine argon and CO2, because that gives us a nice balance of penetration versus spatter. Argon CO2 blends are also important for changing your transfer method. So there's a handful of transfer methods that MIG welding uses. The one that's most common for us is short circuit as a transfer method. It's for like thinner materials, kind of less heat energy putting in there. That's 75-25, use it all the time. If you wanted to go to like a spray transfer, so a spray transfer puts down a ton of metal, usually for like thicker things. To do that, you need to increase your wire feed speed, increase your voltage, and you need to change your gas. The gas needs to have at least an 80% argon component. Most folks do like a 90-10, so 90% argon, 10% CO2. You might see out in the world, or you might have done this yourself, where you're like, hey, I'm doing a spray transfer. I really pumped up my wire feed speed, my voltage. Yeah, here I am spraying. If you still are running 75-25, you're not spraying. You're just running an extremely hot short circuit. So it's important to go ahead and make sure you change those gases if you're changing that transfer method. You can use helium with GMAW, so that helps to add more heat transfer for thicker materials, especially like aluminum. A lot of times you'll add helium for aluminum, and then you have special mixes, those tri-mixes we talked about before, very specifically tailored for welding to achieve particular mechanical properties when they're done. Looking at GTAW or TIG welding, the shielding gas protects the weld pool and then also your tungsten electrode from oxidation. It's very important that when you are TIG welding, you're keeping everything in the gas. So when you're dipping your rod, moving it around, anything like that, you really got to make sure that it's in that gas envelope, because the minute it leaves, it's going to oxidize. And we don't want to get those little oxidized particles into our final weld. Argon is the most widely used shielding gas. Very stable, consistent arc. Helium was what was originally used. That's why you might see the term heliarc for TIG. So that was like kind of the original description. Helium we will mix with argon for that better penetration. Again, like I said, with aluminum especially, really helps out because that aluminum disperses heat so fast. We got to get some more heat in there to actually be able to melt and make the weld on thicker pieces. But helium is kind of like a one-time use gas. So we switched to argon because it's heavier than air. We can keep getting it out of the atmosphere. Helium is lighter than air, so once you use it, goes up and exits the atmosphere. We don't have a lot of helium that's accessible on Earth right now, like we're running low. They did just find a ton in northern Minnesota, up in the Iron Range, that could like super like change the industry. But they have to actually get it out first. So we have a lot of potential helium to use, but the actual helium is decreases every time anybody ever uses it. Hydrogen, you can mix that with argon for reducing atmosphere, give it some cleaner welds, but there's a big risk of what's known as hydrogen embrittlement. This is where we get hydrogen stuck in our molten metal, and then it'll come out later as like a cold crack, if you've ever heard that term. When it comes to preventing gases from getting into our welds, overall, people are like, water is an issue, moisture is an issue. It is, but more precisely, it's the hydrogen. Hydrogen is the issue. It's the smallest element. It's number 1 on the periodic table. So the smallest atom, it can really just fit into anywhere. So when you heat up the metal, you're moving those, that like crystal structure of the metal apart, and all those spaces in between the individual cells, you can get hydrogen in there. It coalesces, it gets stuck, and it provides a little bit of pressure, and that pressure is enough to make a crack eventually. That's why we have like low hydrogen electrodes, that sort of thing. Nitrogen, not used a lot for TIG, but can be applied for especially materials like copper. Looking at oxyfuel welding and cutting. So this is where we're going to be combusting gases to create a flame. Acetylene, I said, is the most common one. It's not the gas that produces the hottest flame, as it says right here, but it's the gas that's most commonly used that has the hottest flame, if that kind of makes sense. Propane, less expensive alternative for cutting and brazing. Usually we're not going to use it for welding because of that lower flame temperature. You might have heard of MAP gas, so that's the methyl acetylene propylene. If we look at the word, the methyl acetylene propylene, we can kind of take some parts out of it. So it's got some acetylene in it. Looks like it's some sort of propane maybe thing. So it's a hydrocarbon, and it was developed to be more stable than just acetylene on its own. And then finally, the oxygen enhances that combustion, part of that fire triangle. And then when we are doing our oxyfuel cutting, like I said previous, you're doing that rapid oxidation and blowing out your like little trail of rust, and that's how you make your cut. Last one, I believe, for our processes and gases is PAC, or plasma arc cutting. So this is where we use gases to create a plasma arc and provide shielding. Plasma, for a quick refresher, is the 4th state of matter. So the other 3 are solids, liquids, and gases. Plasma has characteristics of each of those 3, but it's not any of those 3. So it kind of has little pieces of all of them. We see plasma all the time out in the world because it's lightning. That is a bolt of plasma. So when you're doing plasma arc cutting, it's kind of cool because you're actually making a lightning bolt. Then you're using gas to like shape it and control the lightning bolt. And then that's what allows you to do your cut. So compressed air is most often used, very cost effective. You can get it from anywhere, but you gotta make sure it's clean. So, a lot of filtering, make sure it's not too much moisture. Nitrogen is also used for stainless aluminum. And then you can get an argon hydrogen like mix. That's for cutting on thicker stainless aluminum. All right, some safety considerations. So there's a lot to go on here. I'm going to hit like some key stuff. I definitely encourage you to go ahead and pause if you want to read like deeper into this. If you want more information on safety things, hit me up, get a hold of MO2, and I'd be more than happy to apply things for you. I will say that when it comes to safety, the number 1 rule is you're in charge of your own safety. So we're not going to expect anybody else to keep us safe. We have to keep ourselves safe. And then also, like, complacency is an issue. So if you use industrial gases every day, you are like, hey, there you go. This is how I do it. This is the right way. Well, it could be, but also things change. New guidelines come out, safer ways of doing things are developed. So my big thing, I guess, would be is take safety seriously, and you're in charge of it. So, if you want to make sure that you're handling these things safely, you have to make sure you're handling these things safely, if that kind of makes sense. All right, so handling always going to use a cylinder cart. Always have the cylinder strapped to your cart if you're moving it around. We're not going to use them by a cap. We're not going to roll them on the ground, like on their side. We are going to avoid dropping or striking them. We're going to keep empty ones away from full ones. When it comes to storage, we want to make sure they're well ventilated, dry, secure area. We want to keep them away from things that could like really change their temperature or create instability. So we want to make sure they're away from like direct sunlight, open flames, extreme temperatures, especially if we're looking at flammable gases. So flammable gases and oxidizers, they need to be at least 20 feet apart, or there has to be a fire-resistant wall separating them. Last time I checked, and this is one of those things to verify, it was a fire-resistant wall with like a half-hour burn time. That's what we need to have between that fuel gas and that oxidizer. You want to always use racks, chains, stands to secure cylinders. We don't just want them standing out by themselves. And the whole point is, well, with the number 4 here, we got to make sure the valve caps are on. The whole reason is with a high pressure cylinder, you tip it over, you break off the valve, it turns into a missile because all that pressure is going to be coming out of a very tiny little hole where that valve was, and it's going to shoot wherever. So very important. All cylinders we need to secure, but especially the high pressure ones. Ventilation, got to make sure we have that good ventilation to prevent accumulation of flammable or toxic gases. In addition, in confined spaces, we got to make sure our oxygen levels are good. Something like argon, which is inert. Argon is not poisonous. It's not like you breathe it in and you're going to start like choking or something like that, but it is heavier than air. So if you're breathing in a bunch of argon, or you're in a depression or a lower area and you're welding, the argon will eventually push all the oxygen out, depending on how long you're in there. This happened to me once, and I've known it happen to other people, where I was TIG welding kind of like in a depression, and it got really hard to breathe. And I wasn't quite sure what was going on, but somebody told me, hey, basically like put yourself upside down, like lean over like a table or an edge of something, and then like cough or like breathe really hard to get that argon out, because again, it will just sit in your lungs. So you want to be very careful. If you're in a space where that argon could collect, if you're able just to move the air, so put like a little fan to just get some airflow, but not blow away the shielding gas from where you're welding, that should take care of the issue. Always for identification, you got to make sure that what's in the cylinder is correct. Don't trust like the coloring of the cylinders. Oxygen cylinders can be green, they can be red. Acetylene cylinders can be green, they can be red, right? So read the labels. Always read the labels. If the label is illegible, so you can't read it, return it to your supplier so you can make sure you're not going to be using something that is could be dangerous. And labels contain the gas name, hazard class, safety precautions, all those sort of things. All right, leak detection. We want to make sure we check for leaks. A couple different ways to do this, but we want to do it regularly. I like to do it like every time. Basically, I hook up a new cylinder to either a machine or a manifold system. It takes 5 seconds, and at best, well, maybe at worst, you're going to prevent yourself from just wasting gas that's leaking out. At best, you could prevent either poor weld quality from like atmosphere getting into the lines, or if it's a fuel gas, you're preventing like an explosion or something very serious happening. So I definitely suggest just do a quick leak check every time you hook up a new cylinder. Fire explosion hazards. So we talked about that a little bit earlier, but keep the flammables, those fuel gases away from oxidizers. There's certain distance, wall in between with a certain burn rating, that sort of thing. Flashback arresters in your like oxy-fuel torch will prevent a flame from going back into the system to your like fuel source. Make sure there's nothing that can start on fire anywhere we're using this stuff. And use equipment specifically rated for the pressure and type of gas. That's a big one, because I think a lot of people who use oxy-fuel don't reference like cutting charts and things like that for PSIs. And it's important, because if you are like using like a cutting tip and you can't get through a material, you don't improve your chance of getting through by like turning up your gases. So the tips are designed and the torches are designed for a certain amount of flow. So let's say you're cutting something like that's like 2 inches and you can't get enough heat to actually cut through it. Don't turn up your fuel sources. Don't turn up your oxygen. You need to switch out your tip to a tip that can accommodate a higher flow rate to do that sort of work for you. So I think that's super important. The settings of oxygen and acetylene are there for a reason, preventing that drawing of acetone into the system and whatnot. So please, please, please reference them. Plus, they're different for different equipment. So if you're using a Smith, reference their information, Victor, reference their information, that sort of thing. It's not that just like one size fits all. Emergency preparedness, you should have SDSs, so safety data sheets for everything you're using. They're great because they tell you what it is, what it's made out of, what to do if you're exposed, that sort of thing. You can have gas detection systems, all the appropriate fire extinguishers, that sort of thing. And then finally, training and awareness. This kind of goes with what I was talking about with the oxyacetylene. You want to make sure that people are regularly trained to remember those good habits and to keep practicing them. So make sure you have good posted information about the hazards and what to do, and then also that regular training. All right, challenges in the future. So some challenges that are in the industrial gas world, environmental regulations and decarbonization. Touch on this with the CO2. With the stricter regulations of carbon emissions, we still need CO2 to be able to do a lot of stuff in our industry. So you got to really try to find that balance between sequestering to prevent any sort of increase in the greenhouse effect, and then also making sure that the industries have what they need to be able to produce their products. Getting gas or separating air into your different gases is very energy intensive. So you got to make sure you have good infrastructure for that. There's limitations on places where maybe the electrical grid is not going to be sufficient enough, or transportation storage facilities are not what they need to be. Supply chain disruptions, so we've seen that with COVID. Also, like with things like with tariffs, stuff like that, that can do supply chain disruptions, not only for like the gases themselves, but for components of like a gas system. So like all the high pressure gases are in cylinders. You know, most cylinders are made out of steel. So if there are like pricing issues with steel and that are affecting like importing things from overseas or importing cylinders that are made from overseas, that will affect the industrial gas industry. Market competition. So there are challenges with the market competition and the consolidation of the industry. A lot of I guess like independent distributors are kind of being, this is from what I've seen. It looks like there's more independent distributors that are kind of being like folded into your larger suppliers. And so when you consolidate the industry, that sort of thing, it just makes the ability to get the best prices more difficult. So that's something to like look forward to. Also, use your independent distributors. They're the best. And then finally, gas scarcity. So we talked about like helium, that sort of thing. The other thing with gas scarcity is a lot of the rare gases are from the Ukraine, for instance. So like geopolitical issues, war in Ukraine, that's going to affect that supply. And I believe this is the last content slide. So looking at the future, some things that might be coming down the pipe. We got the focus on green hydrogen, which is pretty awesome. That's where we're splitting water to get energy. There's a ton of energy that's released when we go and split water into oxygen and hydrogen. Carbon capture and storage, we've talked about that several times. Probably going to continue as far as I can tell. Integration of renewable energy. So renewable energy like sources require specific gases, and we talked about in the last slide how energy intensive the process is to separate the gases. So how do we integrate renewable energy sources into being able to provide enough power to continue to manufacture the gases? There's advanced cryogenic technology. So cryogenic is when we have like gases in a liquid state. So improving how the efficiency of those, and also how the scalability, so how large we can like make containers for them, that sort of thing. Digital transformation that's everywhere to optimize production, distribution, monitoring. And then there's more what are known as spec gases used in high-tech industries. So onshoring of like semiconductor manufacturing, that sort of thing. There will be more specialty gases that are needed for those specific industries. Kind of a long one today, folks. I'm glad I appreciate if you've carried on. Oh, there's like 2 of me on the screen. That's crazy. Well, regardless, here's some of the resources. I believe I added another one for this week, which is GATA down at the bottom. If you're not familiar with GATA, MO2 is part of GATA. It's the Gas and Welding Distributors like network. Super awesome organization. Nice one of me again. So if you need anything from MO2, please give us a holler. Got lots of services, solutions for you, and really appreciate you tuning in for this week to learn a little bit about industrial gases. Thanks. See you soon.